Buenos días a todos. Muchas gracias por estar aquí. La doctora Mariel Ollervides, que está aquí con nosotros, pues nos va a estar guiando a través de este viaje, ¿verdad? De tecnologías disruptivas. Y bueno, muchas gracias. Le damos un aplauso a la doctora para que inicie el evento. Gracias.
Gracias, doctor. Okay, good morning to all those who accompany us today. To our honorable guest, Timothy Hoff, Jose Alfredo Perez Bernal, and Richard Magnan, who couldn't be here. Also to the members of the academia, industry representatives, and directives of the Tecnológico de Monterrey. Good morning. And a very warm welcome on behalf of the organizing committee, the Institute of Advanced Materials for Sustainable Manufacturing, to the Blue Future of Sustainable Manufacturing Conference. I am Dr. Mariel Ollervides, and I will be your MC for today's program. We appreciate you taking time off of your schedules to join us here today. Here we have reunited leader investigators and representatives of the industry for them to share their knowledge and experience regarding novel materials and the impact of the development of sustainable manufacturing in the transformation of industry. Now, to kick off this morning program, I am pleased to invite Dr. Arturo Molina, Director of the Institute of Advanced Materials for Sustainable Manufacturing, Timothy Hoff, CEO and owner of Colorado Clean ASW, Jose Alfredo Perez Bernal, General Director of the Institute of Innovation and Technology Transfer of Nuevo León. To deliver a welcome message, gentlemen, please, we will receive Dr. Arturo Molina. Yes.
Hello, everybody. Welcome again to Tec de Monterrey. As you know, Tec de Monterrey is really committed with the idea that we can really have a bright future on sustainability. And that's why we have really launched an initiative which is very, very important. Part of what we have been doing at Tec de Monterrey is create 3 institutes of interdisciplinary research to try to tackle the problems that we are seeing as important for Mexico and, of course, Latin America and the world. The next one, please. These 3 institutes that we have. Can I do it here? No. Okay. Next, just. Thank you. So we want to tackle the problem again. We want to tackle the problem of education. We want to tackle the problem of obesity, and we want to tackle the problem of manufacturing. And why is this important? Because we believe that our students, our professors, and our collaboration with different stakeholders, industry, government, and of course society will help us to really tackle these big problems. Education, because we believe that a country that has a foundation of education can really make the difference. And that's why we believe that we can really contribute to how we can reduce the gap of education at different levels in Mexico and Latin America. Also, one of the problems that we are facing is health. And in Mexico and Latin America, obesity is one of the key sickness that we are really trying to confront. And also because the health system cannot support really the sickness that comes from obesity. So that's why we also want to tackle that problem, but from different perspectives: how we eat, how we do exercise, how we do mental health, and so on, so we can really tackle the problem of obesity. Last but not least, we will talk about manufacturing and sustainable manufacturing, because Mexico still is a manufacturing country, even though we are trying to move towards this idea of how we can become a more knowledge-based economy. We want to really have and create our foundations on what we have been so far, which is manufacturing. Again, the next one, please. So the idea of this center is that we want to tackle the climate change challenge. And we want to know that it's very important that we really find certain solutions in terms of what we want to do in terms of climate change. And of course, when we realize and we analyze the problems that we are facing in Mexico, we define it that one of the important aspects that we have to really tackle is how we are going to evolve our industry to become more sustainable. Next, Mariel, thank you. And why manufacturing? Because manufacturing in Mexico is still a large percent of the GDP, 70%, also employs more than 20 million people, and of course, it represents 89% of our exports. So if we think about manufacturing, we think about that a really big industry that has to really become more sustainable, because one of the major problems that we have is that, of course, the industry, again, clicks please, the industry, of course, uses a lot of the greenhouse emissions, also use a lot of energy, and of course, is part of the important part of what we are doing in CO2 emissions. So that's why we believe that it's going to be very important to really tackle the problems of the manufacturing industry. That's why we create this institute with the idea of really trying to do a new type of materials, advanced materials, that allows us to be these type of materials that are recycled, reused, and of course that we believe that if we can really design advanced materials that then can we manufacture in Mexico, we can make a difference. Next one, please. And then our goal is we want to contribute to the carbon neutral economy, trying to discovery, trying to develop and create advanced materials, and try to achieve what we call it a sustainable manufacturing for Mexico. And welcome here all our guests, team, welcome to be here. And of course, our guests, and I will pass the word to whatever is next. Thank you very much.
Thank you, Dr. Molina, for your kind words. Now, let's receive Jose Alfredo Perez Bernal to give us some welcoming words. Thank you.
Good morning to everyone. Thank you, Arturo. Thank you, Tim, and all the tech crew for receiving us here at this moment. We are a public agency of the New Leon government, and we are very pleased to help the ecosystem, the innovation ecosystem, and the science and technology ecosystem, as we call it. And we're very proud to work with Tec de Monterrey and the companies that are looking and searching forward for advanced materials, and the technology can be at service to the people. We have been recently have a crisis, water crisis, and that make a conscience in all of the participants in the ecosystem. And government is not the only that it's trying to improve things. We are working together hand with hand with Tecnológico de Monterrey, and I want to make a public reconocimiento público. I want to recognize Tec de Monterrey because they have to make team. They work as a team, and they work very hard in the ecosystem of innovation and science and technology, and we're very proud of that because it's difficult to find people that are caring by other people. We're talking about, we were talking with Tim about that, and we say it's very difficult. It seems to be very easy, but it's not happening every day that people caring for other people. We are a public agency, as I say before, of Nuevo Leon's government, and we want to send you a message that we are facilitators. Gobernador Samuel Garcia has told us government has to be a facilitator of the public policies. That's our mission there. Collaborative vinculation and working as on one team for the greater good of Nuevo Leon and Mexico. And I thank you for this invitation, and I'm very interested in hear what is gonna tell you, what Tim is gonna tell us about what they are doing right now and how we can collaborate to make it happen. Quiero agradecerles mucho la oportunidad de estar acá. El gobernador nos ha pedido que seamos facilitadores del medio ambiente, del ecosistema que tenemos de ciencia, tecnología e innovación. Y para nosotros es muy importante entender el rol de llevar las políticas públicas no solamente en un papel de ley, sino hacer que se vuelvan prácticas, que estén al servicio y en la utilidad para todo el ecosistema que nosotros conocemos como ciencia, tecnología e innovación. Estamos muy contentos también porque de los 3 institutos que presentó Arturo, uno de ellos tiene su sede en el Parque Pitt, que van a encontrar ustedes rumbo al aeropuerto, a 5 minutos del aeropuerto. Es el Parque de Innovación, de Investigación e Innovación Tecnológica que tenemos acá, que se creó desde 2007 a la fecha. Ya son más de 15 años trabajando en este ecosistema con una visión de futuro de largo plazo, implementando políticas públicas, pero facilitando a la iniciativa privada, a la academia y al gobierno una interacción y una colaboración única en un ecosistema que no se encuentra en otra parte de México, y no es pretencioso decirlo porque yo apenas tengo 1 año ahí, esto ya estaba ahí y nosotros tenemos la obligación no solamente de mantenerlo, sino de hacerlo crecer a un siguiente nivel para que se pueda aprovechar por el beneficio y el bien de la empresa de Nuevo León, de la academia de Nuevo León, del gobierno de Nuevo León, pero sobre todo de la gente de Nuevo León. Y esa es la parte que el gobernador nos ha pedido muy encarecidamente, que estemos trabajando en equipo, en conjunto, y el TEC trabaja en equipo. El TEC sabe trabajar en equipo y tiene un alto compromiso social, y no pierdan duda o no tengan duda, mejor dicho, que los valores que el TEC ha infundido en sus alumnos los está llevando a la práctica, y yo lo veo con el espíritu de colaboración y la forma en que nos hemos podido relacionar con el TEC, y que siempre están viendo más allá, y ahora estamos viendo no solamente por la localidad, por Nuevo León o por México, estamos viendo por el mundo, y esa es la parte de interactuar con empresas de Estados Unidos y de otras partes del mundo para hacer que estos esfuerzos se multipliquen y entender que el cambio climático es una realidad, que el mundo está cambiando, y no necesariamente solamente en aspectos buenos, sino también en aspectos malos, y más nos vale poner manos a la obra para hacer que ese cambio pueda impactar de una menor medida nuestro medio ambiente que tanta falta le hace, y que no hay otro mundo, este es el mundo que tenemos y el que tenemos que cuidar, y en eso estamos abocados a colaborar con el TEC de Monterrey, las empresas que están convocando y por supuesto el gobierno poniendo su parte y su colaboración. Muchas gracias.
Thank you, José Alfredo, for your kind words. And thank you, Dr. Arturo, for your welcoming words. Now, moving on, let me introduce you to our first speaker this morning, Timothy Hoff, CEO and owner of Colorado Clean ASW, who will present us the conference, The Future of Sustainable Manufacturing. Tim Hoff studied chemistry at the University of Northern Colorado from 2000 to 2004. But his real passion began 10 years ago when he devoted his life to the engineering of biopolymers. This led to 2 years later patenting his amphora film, a first of its kind in the industry. Tim has worked with leading manufacturers from DuPont, DOW, Total Covion, and Mitsubishi Chemical to develop some of the most cutting-edge biocompounds. Along with his research and work with biotech and bioprop, global on bioadditives, Tim Hoff's motto of being fluid has sent him on a path to disrupt the world's culture and understanding plastics and polymers as we know it. Tim Hoff, CEO, President. Colorado Clear packaging is 100% biodegradable amphora film. Our water comes from the Grand Mesa Rapid Creek with a pH of 8.5, including all natural minerals and electrolytes. Colorado Clean ASW LLC, sustainable bioplastic manufacturing, 100% biodegradable amphora film, has a shelf life of 10 years and is medical, food, and oil field applications approved by material by the FDA and audit. International Waters Incorporation manufacturer disasters and relief emergency mobile stationary water purification and bottle systems designed to purify any water source and bring it to safe drinking levels to those in need around the world. The Swan Foundation donates 1 EWPBS from the International Waters Inc. for designing systems to our global communities. Now, please, let's welcome Tim Hoff for his talk.
Thank you for the warm introduction. So first of all, I'll mention, I want to thank not just Monterey Tech, but the whole state of Monterey, Nuevo Leon, the country of Mexico. You guys have been overly welcoming to me, my family, my team, and it's just, we have fallen in love with it. And we see how, with open arms, your guys' vision for the circular economy and the circular environmental economy is actually becoming very embraced, and it's becoming a culture of your guys' community. And Roberto and I discussed this in depth on how it needs to be started in a room like this, where it needs to become a cultural, just ingrained into your DNA of every day that you think about what you're doing and how it needs to be part of it. So like I have a big long speech written out, but as you've heard, our company motto is be fluid. And as I met people today and spoke to them, I have a few other things that I will talk about, but we will cover a wide range of topics. So I hope I don't bore you, but we're going to be covering a lot today. But thank you again to Monterey Tech. Thank you to the country of Mexico. Thank you to everyone. So that's the main thing is how grateful we are. So I kind of want to explain to you guys how our company actually came to be. About 10 years ago, I already had a background in chemistry, mathematics, physics, but it wasn't the whole focus of my life. I loved it, had a passion for it, but I didn't really understand where I was going to take it with my life. So I was actually horseback riding on the Rocky Mountains in Colorado about 2 days in, already passing into Utah. And I came across a pile of PET bottles and trash where cars can't access, cars can't do it. This is 2 days of up in the mountains riding, and I found trash. And I was infuriated because my church is the mountains. My church is the water. My church is everything outdoors. And I was so upset on how someone could just destroy our environment like that. So I actually sold off. I had a tech company at the time, and I devoted my life to biopolymers. And when people hear like you devote your life to study, I am very envious of your guys' institute and your university. And some of the university officials might be a little upset with what I did. I moved into my grandmother's house because she was 2 blocks away from CMU, Colorado Mesa University, in our town of Grand Junction, Colorado. About 17,000 students, but not near as nice as your facility. And actually had some friends that were in the administration make me a TA, a teacher's assistant badge, so that I could access laboratories, the administration, I could access all the computers. And I spent years studying biopolymers. And I would sneak into laboratories, running tests without even, because I couldn't afford it, I dumped every penny I could into my passion. Well, 2 years of that came out with amphora film. This is our amphora bottle. It biodegrades in 13.5 months, compared to a standard PET bottle, which is over 700 years. So this springboarded us into the market of biopolymers. And when I mean springboarded, it launched us down, I'm sure a lot of people understand the word, a rabbit hole, because we saw so much of a need of so many different polymers of what's in the industry. And so I encourage every one of you that are sitting here, when you come down, walk our tables. We are covering over 40 different types of polymers that we have made biodegradable with our products here. and this is only a fraction of it. You have from automotive, footwear, healthcare, obviously food packaging, anywhere from polypropylene, PET, LLDPEs, nylons, you name the polymer, we are trying to work at building additives for it. And that's where the people don't understand. Here's the past advancements in biopolymers. A lot of people in this room may understand the term oxo-degradable. And when people hear biodegradation, you think OXO or D2W, and that causes fragmented plastic, microplastics. Oxo-degradable, for example, if this was an oxo-degradable bottle, the minute it hits sunlight, oxygen, any atmospheric, it starts to degrade. That was why I wanted to develop something different, because what's the last thing that I want to give my friend's child or my elderly grandmother? Something that's degrading right there, because you know what leaching is. It'll leach polymers into it, create microplastics. So we created all of our products only biodegrade in anaerobic environments. Two largest anaerobic environments on our planet, A, a landfill, 2, an ocean. All of our products are recyclable, but we want to know if someone doesn't recycle them, because I'm sure you guys are very familiar with the percentages of plastics that do not get recycled, and it's very sad. In the United States, where I'm from, 97% of all plastics do not get recycled. And so they're either incinerated or they're sent to a landfill. Even though people think they're doing great and you recycle them, it's actually worse. And I've actually spoke to our government about it, on how sad it is to know that we are paying a recycling company to drive it 300 miles to get it shredded, then it's baled, then it's drove another 1,000 miles, and it sits in a storage facility for 30 days before it's incinerated or goes to a landfill. The United States used to send it to China to be recycled. China no longer takes our trash, so we are dumping it. And when I had the pleasure of seeing what you guys were doing on campus, and I was thrilled seeing the collection. And I wanted to discuss with them, and Arnulfo got their contact information. If you guys are familiar with RPET, our PET market has grown over 300% in the last 10 years. You guys have a revenue stream right here on campus that you guys can be developing RPET very easily. And we actually developed an RPET plant with my friend Ari Lasky, who I wanted here to be today, but it's young Kapur. He can't make it. But we built an RPET plant in Houston, and he's doing it just off the 5-gallon jugs that are recycled through Walmarts and other distribution centers. And it's a moneymaker, it's revenue here on campus. Sorry, again, like I said, be fluid. I get off topic, but I'm passionate about what I do and what I see of everything that is possible here. Okay, so currently, I discussed a little bit. We are working with mostly 40 different polymers that we can engineer almost any product for almost any industry. The key is understanding in manufacturing. People, when they hear how much do you have to change, our additives are only added at about 0.5 to the maximum of 1%. So the industry, a company, will not have to change any of their machinery, because that's a huge thing. Think about a company wants to do the green thing, but they look at the bottom line. Let's be honest. Everyone has to look at the bottom line. I have to look at the bottom line. If you have to retool to change to make something biodegradable, not going to happen. Oh, thank you, so I can walk around. Thanks, Arnulfo. But yes, so that is one of the biggest things is you want to disrupt the environment or disrupt the economy a bunch, but you can't change everything. This, for example, when you guys come up and look at it, this is biodegradable EVA on the soles, and then all the fiber is made from hemp. So this is 100% sustainable footwear that will biodegrade and it can compost. So that's what I'm saying is we like to get challenged. Here's one where we got asked about eyewear. Can you make glasses biodegradable? Do you know how much waste this is right here? You have to shear everything off to make the lens. This is just the plaque for it. The rest of it that's sheared goes into the waste. And people don't recycle it or think about it. The waste of the human environment of what we're doing is, I'm sorry, it pisses me off. It is sad, and and I have to do it. So we've talked about kind of the past and what we're capable of doing, but where I see the future of going with biopolymers. Roberto and I and Dr. Alex have talked about not just with biopolymers, but working with enzymes. Enzymes, I really see, is going to be the future of, because that's the main thing of these biopolymers. When this goes into a landfill, all the microbes and enzymes see this as food. This is a banana peel to them, and they consume it, and they build a colony around every millimeter of it. So that is, their research with enzymes is going to change the future. Enzymes are great, because when some companies or some people hear the word methane, do you know methane through 2 other stages of process can become natural gas? Methane, if you're capturing it, is a great thing. Methane also disperses in the atmosphere in under 7 years. It is one of the fastest natural gases that will disperse in the atmosphere if it's not captured. Clean methane is amazing. Natural gas, and when they were talking about getting away from fossil fuels, we're going to touch base on that a little bit. So the other big thing that you guys have heard that one of our passions is water. That's how kind of I got started in it. I saw the pollutants, I saw everything. So when you guys come up, I brought some of these samples of them. And when you mentioned that it's from Rapid Creek, Mesa, I actually have a swan on there. The swan is an interesting story. The swan is on the Grand Mesa. It came from the Native Americans. The reason why the swan, it's where the snow is on the mesa. Well, when the swan's neck broke is when the Indians knew when to plant. Farmers to this day still follow that mantra. Well, my grandmother's last name was Swan. And when I started working on these bioplastics, I mentioned earlier I was living in her house, sneaking into the university, and I would bore her every night talking about bioplastics and what I could do. And she finally yelled at me, quit talking about it and just do it. And that's why you heard we have the Swan Foundation where we donate the water. Because sometimes you need that little kick to keep moving. So as I know I've kind of rambled on a little bit, but with Roberto and the University of Monterey Tech, we have discussed some of the other advancements, not just doing bioadditives. We are now developing anaerobic digesters with companies here in Mexico. Anaerobic digesters, when people would see it, think of a large football pitch. 120 cubic liters were involved. We have now scaled them down to 3.5 cubic liters. The idea of having an anaerobic digester with only 3.5 cubic liters of material and 50% of it running off sargassum that you guys have already on your, and then the rest being organic food waste coming from cafeterias, restaurants right here on campus, it can power 1.2 kilowatts per hour per liter on your campus. And the idea of having that small a thing, that's not just talking on college campuses, it could be every hotel, every business that has it where you can have the organic waste. And now you're handling waste, generating energy. And now we're going to get into one of my pet projects. So they mentioned that I love doing water treatment and water for needy or people in need. I did water purification. We built 20-foot shipping containers that could do 3,500 liters an hour, bottling these. One 20-foot shipping container holds 3 million bottles of these. It's equivalent to 110 semi-trucks. Those, we started building those. Well, then I saw, and after I became so good friends with Arnulfo, Francisco, all my friends in Mexico, seeing that there are communities that we cannot just purify the water, we need to do it. So we started working with atmospheric generation. The problem with atmospheric generation, technology is there. The problem is these things take so much energy. So what community that doesn't have water is willing to pay? You're not going to fill it. You're not going to get diesel generators out there that it needs 120 kilowatts an hour to run it. No. So we designed anaerobic digesters with solar to run an atmospheric generator. So think about a community that can generate its own clean water off its own trash and not have one lick of fossil fuels. And that's one of our goals. And every single one of these products that you're seeing, the reason why they're bagged up, they are going into an anaerobic digester for testing to see what their gas offsets are going to be. So again, closing comments. When you guys all come up, I'll be standing up here to answer questions. Come see our samples. And again, I apologize for rambling, but again, I'm passionate and I love what we do. But again, I look forward to working with Monterrey Tech and the whole country of Mexico. And I thank you guys so much. Thank you.
Thank you, Team Hub, for your amazing presentation. Now, we have a few minutes until 11 for some questions and answers that you might have for Tim.
Thank you, Tim, for your presentation. I wonder about this idea of house technologies. So we as citizens can really have in our house all these new type of technology like digesters or generation of water, capturing water from rain and so on. And I believe that that could be a solution, towards helping, the environment. What do you think about it? House technologies for doing all these kind of things.
Well, actually, I think that's a great question. I believe it starts right here on this campus. It becomes a cultural idea. The students of Monterrey Tech, they spread it to their friends, they spread it through social media, where it just becomes not just a social commitment, it becomes a cultural commitment, and it becomes your ideology. So just to say every single day, I can do that. No, just to say, knowing every day that your product is either zero fossil fuels, or if it isn't, it's either biodegradable, compostable, and it becomes a cultural and it becomes a belief system. And I believe that's where the circular economy is so important, to do it that way. But no, it needs to become a household thing. And once the people react and they demand it, the corporations and the factories will follow. And the governments will follow also. And to touch base on that, how I'd heard about single-use plastics were banned in Mexico. I had heard about it in the U.S. I was already manufacturing bottles and stuff down here in Mexico. But until I moved my family down here and we went to the grocery store and I could not get a bag, then I believed it. Because in the U.S., you ask for a plastic bag, it's still there. We have not made any effort. And that's why I'm very happy about seeing your guys' whole cultural belief. And I believe it is becoming systemic, that it is becoming a household belief. Thank you.
Thank you. Is there any other questions from the audience? Would you mind coming up?
Oh, thank you. Sorry.
Hi. You mentioned our PET as a viable solution to plastic and to circular economy. How do you propose we can make more efficient the reverse logistics to recycle it?
Well, for example, our PET is one of the most amazing things. It can actually be processed up to 30 times before you start seeing degradation of the material. So every time you recycle this, instead of it going right to a recycling center and it either gets shredded and landfilled, small RPET plants can make this right into a pellet where companies are actually begging to get supplies of RPET so they can either run 100% RPET, 50% RPET mixed with, the other 50% virgin PET, because they understand the sustainability of it. The one we built in San Antonio, it was under $300,000, and it's a complete line that it runs 24 hours a day, and they cannot keep up, and everything is pre-sold 5 years out already. So RPET, and when we're talking to them, how many tons are they collecting? The company that we talked to yesterday? 7 tons a day. Yeah, 7 tons a month? Yeah, 20% of all that is collected is actually getting recycled. Yeah, so 80% of it could be made into an RPET plant. And sorry, I'm putting you on the spot. Think about all the engineering students and the business students here on campus, even the industrial designing it, where that's on campus, being done. And do you know how much global publicity that would get of that coming in, where students are doing this, and it's a huge industry, and it's making a business model. So you have business students seeing on the global economy of it. You have industrial designs designing the new layout of the new equipment. Great question. RPET is one of the futures, probably in the next 20, 30 years. You're going to see even more of it. Thank you.
Thank you. I think I saw another hand raising. Is there any other question from the audience? Yes.
Thank you. I was wondering, how much time does it take for an industry to accept the new materials you are proposing, or to use them in their manufacturing system of, in the operations of every day? I guess it differs from the shoe industry to the food industry, right? But in average, how much does it take for it to be accepted?
It takes about 3 months to a year. That's our average. The reason being is we run ASTM D5511 tests. And it used to be a year to 2 years on before people would accept them. But now working with international companies like Intertech for doing the ASTM D5511, that's the international recognized test for anaerobic digestion. We have worked with companies now that after 30 days, we put date coding on it where it'll show the biodegradation percentage every 30 days on the products as they're manufactured. So now we have cut it down from over a year to 3 years to now 30 days before it can be launched in the market. Because with laser date coding, you can keep up to date with your testing. It's as quick as one phone call from the lab, email, and then your program is cut it in, and everything that's manufactured will be recoded with the biodegradation rate. So great question. We're down to 30 days now.
Thank you. Okay, thank you all for your questions, and thank you, team, for your answers. Now, please allow me to introduce to our next speaker this morning, Dr. Roberto Parra, leader of strategic projects of bioproduction systems at the Institute of Advanced Materials for Sustainable Manufacturing at Tecnológico de Monterrey, who will present us the short talk, Disrupting Blue Technology for the Future. Dr. Roberto Parra Saldívar is a research professor at the Tecnológico de Monterrey. He completed his PhD in biotechnology at the University of Cranfield, United Kingdom, and his postdoctorate at the University of Westminster in the United Kingdom too. He was a visiting professor at the MIT in the laboratory of Robert Langer and Harvard University. He also belongs to the National System of Researchers. He is a SNI Level 3, and to the Mexican Academy of Sciences. He has taught more than 50 professional and graduated courses in the Department of Chemical Engineering and Biotechnology Engineering, and in the Master in Environmental Systems, Master in Energy Engineering, and in the Master and Doctorate in Biotechnology during his professional career of more than 20 years. He has directed more than 80 national and international projects as principal investigator and is an evaluator of projects in Poland, Singapore, the Netherlands, the United States, Colombia, and Mexico. His metrics as a researcher include a total of 230 published articles and an overall citation of score above 6,300 and an age and index of 40. Now, please, let's welcome to Dr. Parra.
Thank you, Maria. Thank you, Doctora. Thank you, everybody. I'm very happy to be here. I'm going to talk about research because that is my field. I'm still sneaking into the lab and do some research. That is something that always is part of our nature. No? We love science. That is why we are here. So I'm going to talk about what we are doing on research. This is a big problem. I think this is a special moment because we need to evolve into a blue culture. This is the idea. So we need to change our mind. So in that sense, we have research and we have a challenge. That is the idea that Dr. Molina has, the big challenge, and then we will find a way to solve the problem. And we start normally with a basic research, do some bioprocess, some production related to the waste that we are, basically I'm talking about waste from all the industry, and then optimize, scale up, and do some innovation, formulation, and products. This is a circular concept, I would say, to improve, innovate in research. Next, please. So from this part, actually, we are kind of bringing from different areas of research that is amazing because, for instance, this is a research related to perspective of finding new microorganisms that are able to break down molecules or to find a new solution for the world. This part, Dr. Mariel Ollervides is leading this part on this molecular biology part because out there are billions of bacteria with the potential to become a new process or to accelerate the process of degradation. So that is, I think, with TIM we can combine an alternative in the biodigester to finding the right strains to accelerate the process to even reduce more the size of the biodigester. So this is an area that we work here very hard on the molecular, or at the molecular level, to find the isolate, to produce some products, to optimize. Well, next, please. So in this sense, again, we are considering all this impact. We see this problem. This is the first thing we see this problem. We are aware of the problem is getting worse and worse. You know, the big island of plastic floating in the Pacific that is becoming a killer of many species. And also the leaching of bioplastics into the ocean and then accumulating fish. So we need to find a way to make this fast and easy to degrade. So we are trying also to use green factories. This is something that we try to implement. The use of microalgae. Cenedesmus is here, is a microalgae that is able to degrade several pollutants, but also to synthesize some plastics. Actually accumulate 80% in the biomass of plastics. So Also, based on biotechnology, we can control and regulate the synthesis of bioplastic using the cell. So this is something that we are also doing using in the microalgae. We have some projects related to the CO2 sequestration, for instance, using microalgae, and then end up, as we discussed with Tim before, we also increase the rate of planting trees to succeed in the planting trees. This is a big problem, no? Because there is a lot of tree plantations everywhere, but not all of them successfully grow. And that is because there is a problem in the soil. And bringing microalgae is kind of healing the planet in a way. So, okay, this is other project. This is other that we share, the sargassum. Sargassum is really interesting alternative. I don't see as a problem as the ocean is bringing as a big bioreactor, is producing a lot of biomass and a lot of molecules. The whole pharmaceutical industry can live with this. No, it has a lot of very interesting molecules. We're already working on that. Of course, need to implement the logistic of, as Arturo said, the part of how can we avoid getting the sargassum in the beach. That's a big problem. Also, we're working in this area, so we can join forces here. Actually, it will be with Francisco that is in Tulum. Now, that will be very interesting to join forces and try to get polymers from sargassum. That we have this picture, and we expected to have this clean ocean at some point. Next, please. In these regards, what we are doing so far, we collect sargasso from Cancun, Playa del Carmen, and we ship it here, and then do some experiment. We make biochar. That is interesting because it can be a very interesting support for enzymes. So if we make this natural support, we can put our same enzymes there, and we are going to be able to break down molecules or pollutants in water and have clean water afterwards. Also, all the polymers, we work on the polymers. Some material that can be used as a source for food, but this is a very trendy area that we are working currently in the field. Next, please. Also, another alternative that is in Mexico. Mexico is one of the biggest producers of shrimp. But all of these shrimps, unfortunately, an avocado, yes. So there is a big opportunity to turn this waste into product as chitosan and chitin can be obtained from here. And it's a lot of, big area, big business also, because it can be, or it is produced vastly. Also, we as researchers, we know that if we combine the chitosan and waste from mango, we're able to ferment it and produce a very nice set of new chemicals. So we have the tools, the technology to make our next leap forward in research. But it's a matter of getting the connections. That is something also that is very interesting. Next, please. So far we are working in that. Next. So this is, what we are doing now is doing fermentation, not only with the stream waste, but also we are fermenting other waste, let's say from soya. From soya waste, the okara, the okara it has no value. Once you fermented that, we produce a nice food. So again, for food supplement, food source. Next, please. So this is what we are doing. We are making these films made of chitosan and chitin. Also, that this film has the property of antimicrobial polymers. So that is something that we are currently working, and we try to make it bigger and implement it in some as an additive, as part of the new technology of biopolymers. Next, please. This is a waste from agroindustrial waste. We are very interested in this part because, you know, a research that we are carrying out for almost 15 years is on the production of an enzyme, in particular, lacase. Lacase is the enzyme that enables wood-rot fungi to break down wood in the forest. But we isolated this fungi from the Horse Mountain, the Horse Saddle Mountain. There's a landmark here in Monterrey. And that fungi is able to produce lacase, very thermostable. And we are able to use it industrially for different applications. So again, using the enzyme is a good opportunity to get more raw material from nature using a green process or blue process. Yeah. So this is something that we are doing. Next, please. Also, well, this is not only the stream, the sargassum, or the corn waste, also the coffee waste is another opportunity to turn it into new plastics, polymers, and so far we have a very interesting collaboration. We collaborate with all these companies, OXO, with Nestlé now. We try to get it in this collaboration and try to substitute plastic by bioplastic, biopolymers. And of course, this is a virtuous cycle. We don't have the solution yet, but we are going to do it and we will continue working on that. But so far, this is what we are doing. Elda Melchor, she's in Scotland actually working now with sargassum in Europe, because sargassum is not only in Mexico, it's everywhere and it's affecting all the coast in the world. So in that sense, we design some polymers, but also we try to design, you know, from this waste making to a food for shrimp again. And that's the circular economy. You see, there's no waste actually. It's raw material for the next process. So good. Thank you. Next. So this is some work that we're carrying out using curcumin as the potential antimicrobial that has this molecule, and we design nanoparticles to deliver this molecule for the treatment of some illness, and we can encapsulate it using in all the vests for patients or to try to avoid the infections for patients. Next, please. This is a work that we're carrying out with Dr. Sosa that is sitting over there. He's working in the design of passive sampler, and that is an important point to be attentive and monitoring what is in the water, because the water it can reveal beforehand everything happens, what is going to happen in the city. Like COVID, we were working in COVID, monitoring COVID based on wastewater epidemiology with Dr. Mariel, and that is amazing opportunity after the COVID. Of course, we learn a lot of lessons, and one is the water is a very good sensor of what is happening in the city. So we are defining this new based on material, based in, again, renewable material, this passive sampler, and we can collect the molecules that we are interested in to assess what is happening in the city. Next, please. No? Okay. Okay, well, based on that, the sargassum, we make these films, again, to protect patients for infection using these two type of polymers. It's going, I mean, the research is still ongoing, but it's nice to see this polymer is 100% from sargassum. So it's an alternative of many, probably more medical application in this case. We are talking about wound healing products. Yeah, but again, we have a large set of a spectrum, thank you, of different opportunities. Next, please. Well, that's it. That's my contact. If any question, I will be happy to answer. Thank you, thank you.
It's not, okay. Thank you. Is there a question from the audience that would like to do to Dr. Roberto Parra?
About the hydrogels, can you really incorporate different types of properties? Because I
Yeah.
have seen that you can really develop a lot of type of hydrogels to different types of applications. But how you do that? How you do, how do you, from the technology point of view, how do you add properties to the hydrogel in terms of developing new materials?
Yeah, that's a very good question, Arturo. There are two mechanisms. One is the chemical modification of the surface. Another thing that we are trying is to attach new molecules inside, trapped and then release. For example, for the wound healing properties, also we attach some molecules and release. We are studying this mechanism of release of the molecules, but also the chemical modification is something that we don't. Dr. Aelda is working on that kind of research, modifying the surface of the hydrogels. But mainly these are the two we're working. Go on.
No, on your work with enzymes, when you guys are isolating them, are you cataloging them per what they're reacting with the materials, and then culturing to manufacture and keeping that on location?
Yes.
Or you work, fantastic. So is there a way for, say, a corporation to contact you guys to find out what enzymes are reacting with the best materials?
Yes.
My thought is it's not just digesters, but sewage and septic treatment. With those enzymes, it can eliminate a huge sewage problem, pump-off problem, septic. So that's nice that you guys are cataloging, and hopefully there's a way that people can access that, because bioenzymes, it's going to be a future for so many things.
That's right, Tim. This is a future I see. The use of enzymes as the future for synthesis of many molecules is going to be this in this time, I think. So yeah, please.
Oh, no, it's just fascinating. It's been since everything organic was made, enzymes have been here.
Yep. Thank you.
Thank you. Is there another question from the audience? No? Okay. Thank you, Dr. Parra. Thank you, Doctor, for this enlightening talk. Now, moving on to our next presentation, let me introduce you to our next speaker, Dr. Alex Elias Zúñiga, leader of Accelerated Materials Develop Research Unit at the Institute of Advanced Materials for Sustainable Manufacturing at Tecnológico de Monterrey, who will present to us the short talk, A Sustainable Future, the Role of Materials and Manufacturing Technologies in Cleaning the Planet. Dr. Elias is a principal researcher of the Nanotechnology and Devices Design Group, professor of the Department of Mechanical Engineering and Advanced Materials Department. Dr. Elias has published more than 130 articles in international journals and about 120 papers in international conferences and proceedings. Inventor of 6 patents granted in Mexico and 1 in the USA. He is also a member of the National Researcher System of Mexico, he's a SNI Level 3, and of the Mexican Academy of Sciences. He's a co-founder and CTO of SOA4U, a technology-based company. Now let's welcome Dr. Alex Elias.
Thank you very much. I don't know, my presentation is here. Well, I'm going to give a presentation just to talk about what is the role of materials and technology nowadays. When I met Tim and his group, I was thinking about the possibility of how we should change our way of thinking about sustainability, because it's a big issue. And seems like if, for instance, as an engineer, I never thought in the past that dealing with sustainability is nowadays very important for us. So I'm going to talk a little bit about this. This is the main goal that we have here in our institute. As you see, we have the Institute of Advanced Materials for Sustainable Manufacturing. But now what that means for us, sustainable manufacturing, and how we can connect with all these products that have been developed by Tim's company. This is an important issue for us. And I was thinking, first of all, is to understand exactly what are the pillars of sustainability. And when you take a look on that, you see we're talking about environmental issues, we're talking about social pillar and economic. But how about the culture? How about the culture? Because technology are appearing every day. Materials have been developed every day. But just wondering if we have the culture to really have an awareness of what is going to be the future of those products that we are creating, manufacturing, and putting into the marketplace. Seems like if we don't have that culture, so we need to create that culture in all of us. And I believe that is important, at least for me, as an engineer and as a scientist guy, that need to be aware of what is going to be the future of all those devices that we are manufacturing, that we are producing, and we are putting into the marketplace. So it's something that I'm going to deal, and I'm going to show to you how technologies are moving and how we should address or to be aware of what we need to do in order to make, in fact, that the materials be not only recycled, but need to recover those materials and to make sure that they do not longer contaminate or create pollution into our landfills. I'm going to show to you those ideas over here, and you may see this is a great definition that I found coming from Harvard Business Review, in which it is claimed that in business, sustainability refers to doing business without negatively impacting the environment, community, or society as a whole. So it's something that we are doing in our new institute. 79% of companies consider sustainability a culture, a product development initiative. So we need to be aware of that culture. We need to promote the blue culture of sustainability. 83% of our consumers say it is important for companies to design products meant to be reused or recycled. But you should wonder if it is enough to recycle the products. I was attending last week a conference in Mexico City in which I was participating in that. It was an automotive conference, and many people and many companies were speaking about recyclability. But is that enough? Do we have the capacity in the world to recycle all the materials? If you take a close look on what is happening in the world, you are going to notice that only 20% of all the plastics that we are creating in the world are recycled. So what happened to the other 80%? Are put into our landfills and even into the ocean. That is a big problem. If we don't do something and we do not address those issues, so we are going to be in tremendous problem in a few years from now. So it's why, speaking about biodegradability, something that may occur in a short period of time, it could be a solution for all our needs that we're going to have in the coming future. So we need to do something, and this has to happen right now. It's what I am glad really to have the people from the Mexican government, from the state government here, and we need to push those, not only in the universities, but also in the elementary school. Has to be part, the blue culture of sustainability of our every their lives. That is important. And it's what we are trying to push with Dr. Roberto Parra, who, by the way, is a tremendous researcher, and I am glad to share with him some ideas. So we are really happy about that. Here, as a research group, the first two were my main objectives when I joined to this research unit at this institute. But now, take a look on the third one. Now, what I want is also to promote, through my activities, awareness of blue sustainability culture as the natural extension of people. It has to be like computers. Now computers are a natural extension of every individual in the world. So it is important for us to understand this blue culture. And most important is what actions we are going to take as a researchers in order to make this happen. Because that sounds very good, but now let us make it happen. Let us make it occur. So in my research group, we are changing the way we are doing things. In fact, if you take a look on what I have already done in my group, I have been working with several companies not only in Mexico, but also abroad Mexico, but never thought about this sustainability. Why? Why I missed that chain? I don't know, but now it is time for me to make some, or to take some actions in that order. So I'm going to show to you some of our facilities that we are now selling down here in Monterrey, just to make this thing happen. This is a new facility that we have close to the pit. The Institute is making good investment over there, so we are creating the infrastructure. We are putting the labs that is going to make this thing happen. This product that is typically used in the automotive industry, now we are going to be producing over there these kind of products, but most importantly, we are going to take into account biodegradability and make sure that if a car only lasts 10 years or 15 years, make sure that in 20 years, this product is no longer available. We need to biodegrade this automotive part, okay? So we have over there, and you may see we have also, for instance, here we are making some business with this Vertederos, by the way, a long company who is manufacturing all the racks we use in tremendous big computer systems in the world. They manufacture for Google and other companies over there. And Vertederos taking a look and coming into our labs, and they are asking, what is going to be my key performance indicator at the end? Well, you are going to develop new materials, you are going to invent, if it is not available, new manufacturing processes to make sure that also you have into the marketplace your new innovation or your new products. And in that sense, our institute here is going to put or assign researchers, postdoctoral fellows, PhD students, and we are going to create a tremendous environment because, you know, most important for us is our facility is located in which around that facility it is 35, or there exist 35 research centers. So the environment to do innovation and to make sustainable products is very feasible for us nowadays. So I'm happy that team is considering transfer some operations to Mexico, and hope you are going to transfer some to Nuevo León State to start doing innovations together. Okay? So just to show to you some of the things that are happening nowadays in many companies. And you see that in general, people are not aware of sustainability. So as an engineer, we are not taking that into account. But nowadays, we need to do so. You see, small people are thinking about sustainable packaging. I know that people from some important companies are here, but just wondering if you are taking, or you considering sustainable packaging. That's good if I go to the store and I purchase some kind of food, but just wondering what is going to happen with the package in the future. Recyclable is not enough. It's what I have discovered recently. So what we need to do is maybe to move into biodegradable issues. Could be. I don't know for sure, but it could be a possibility. Okay? So I am showing to you what is happening and what is going to happen with the use of plastic in the coming years. As you may see it, the use of plastics are going to be rising. It's going to increase tremendously. So we need to do something about that, because not only plastics are going to increase, but also the waste of those are going to be rise. So we need to do something about that, okay? So just to show to you what is happening also into the automotive marketplace, in which many of those materials for the future are going to be rely on plastics. So we need to do something about that. It's what I was taking a look in these ideas, speaking with the people from the automotive sector, and if you take a close look on that, they are speaking about refurbishing. But for them, refurbishing is not enough. That was the conclusion that we got last week on this automotive meeting. So, refurbishing, recyclability is not enough for them, okay? So, but I'm glad to hear that they are really trying to somehow be aware of what is going to happen with those plastic materials in that automotive industry. And as you may see, they are spending a lot of resources to move in try or to create an eco-friendly manufacturing practices. And it's something that in our case, also we are trying to do so here in our institute, to have a kind of eco-friendly practices in our manufacturing activities. Here I am showing to you just a little bit what is happening into the market restraint analysis coming from this important company that is a Grand View Research company, in which they are talking about the cost of competitiveness and availability of conventional plastic over recycled plastic. So as you may see over there, recyclability, once again, is not an option at all. It's an alternative, but we need to find a biodegradable ways to get rid of the plastics. And just to show to you how many parts of the automotive are in fact composed by these plastic components, okay? So it is a lot of those over there, okay? I think this survey is really like it to me, because it's the question that they launched coming from this Asahi Cashel Automotive Interior Survey, really like it. They were asking the following question to many companies, not only in Germany, but also in the States, Asia, and so on. And the question was, in your opinion, what aspect characterizes a sustainable vehicle? And if you see the common phrase over there, they were speaking about basically recyclability. They were speaking about that. So they said, sustainability for me implies to recycle materials. But is that enough? Let us take a look on that, if it is that enough. Let us move into what is happening to the ocean. I don't know if you're aware, but as Tim and Roberto mentioned, many of the plastic are being thrown away into the ocean. So that is no good, okay? So that is a tremendous problem, not only for our country, for all over the world. And over here, take a look on this last point. As a result of this trash that we are throwing away into the ocean, all marine species, from plankton and shellfish to birds, turtles, and mammals, are at the risk of toxicity. So we need to do something about that. Those over there, you may see the recyclability capacity that we have in the world to recycle plastic from ocean is really limited. So we need to find new solutions. So having the opportunity, scientific opportunity of really biodegrade plastic is an alternative, is an option, and I think we should consider it very seriously. I'm just showing additional data in which you may see that even though many countries in the world are trying to face this problem, still plastic is a big issue. They don't have the capability to really recycle all the plastic that we're throwing away in our landfills. So, are new technologies helping to achieve sustainability? That is the other question that we should bear in mind. And let me show you. Many of us have already heard about additive manufacturing 3D printing. Almost all of us now have been in contact or having used 3D printers. Many of those printers usually print polymeric parts. So have you asked yourself, what is going to happen with those parts that have been already printed? Those usually are thrown away into the garbage. And those plastics, in order to degrade, may take up to 100 or 500 years before degradation. And if you take a look on what is happening in 3D printing technology, you are going to see a tremendous rise on that technology in the world. So we need to do something. It's why we need to be aware of these new technologies over there and see if you take into account sustainability, 3D printing can offer you that opportunity to you. But you need to take, as a culture, lose sustainability. Okay? So just to show to you how this technology is rising in the world, and you may see that nowadays there are billions of sellings in this technology. So that implies tons of plastics that we are now creating in the world, okay? You see that demand that we have in industry by using this 3D printing technology. You see automotive, aerospace, all the industries are using 3D printing technology, even food, packaging, and so on, okay? Are using that. And now to you, just show to you a little bit of these ideas that come from these new technologies. There is awareness of the use of the 3D printing as a sustainable technology, definitely. It's coming from specifically Nanyang Technological University, in which we have also great collaboration with that university. But now to show to you that in fact, 3D printing technology can offer you the opportunity to create sustainable products. But you need to change the way you are thinking about designing, creating new materials, and also performing manufacturing processes. So we need to think to change the way we are doing things. So what do we need to be a sustainable world? This is an important phrase. To promote awareness of low sustainable culture as the natural extension of the people. So it's what we need to do, to introduce this awareness. That's important, because it doesn't matter if I develop a novel material, if I don't take into account sustainability, if I don't take into account the manufacturing processes, so we are not going to be good in the future. So it's why we need to create that. And if you ask to me some question about the use of this technology, if I have already used that technology in important application, I may mention yes. Working with the aerospace sector, for instance, we have developed some important aspects, and we perform a circular economy study just to investigate what would be the impact of 3D additive manufacturing in the cycle, for instance, of building turbine blades for the aerospace sector. And at the end, the conclusion is it is feasible to have a sustainable manufacturing technology. But you need to be aware of that. And you need to take additional steps to design, to material development, and to introduce those ideas into the manufacturing processes. So that is important. So this is the main message that I wanted to send to you. In this institute that we have already launched here at Tec de Monterrey, we are now aware that sustainability is a big point, and that having partners like potentially we are going to have a team working with us together, I think that we achieve a sustainable solution for our world. Thank you for your attention. It's a message that I want to say.
Thank you, Dr. Zúñiga. We have a few minutes for one quick question from the audience.
Tim?
Yes.
No, I'm a big fan of this. One of my quick questions on since you guys are doing and exploring and expanding your 3D printing, do you buy your filament from one direct supplier?
Yes.
Okay. In our talks of collaborations, what about Monterey Tech being one of the first ones to ever develop a biodegradable 3D printed filament for other industries?
Be excellent. Why not? Why
Yes.
not? In fact, we have been working jointly with a group of Dr. Roberto Parra, try to develop new polymeric materials, and why not? We are now thinking in adding biodegradable capabilities with the development that Dr. Parra has been already done and some of the things that you have already done. Why not? It's a tremendous possibility. And you know, that will create a tremendous solution
For, I think, automotive,
society.
aerospace,
for
everyone.
aerospace, for everybody,
Yeah.
because you know, even people from the architecture side also are using this kind of development. I think for the general public, we can create a tremendous solution.
Well,
that is feasible.
We're
Why
going to
not?
communicate on the top 3 materials of the filaments you guys purchased. And
Excellent, 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 team. Excellent. It's a good news. Additional question?
Thank you, Doctor. I have a question for you and for Dr. Timothy, if you let me. I am a medical resident at TechSalud, and my thesis is about whether or not the sustainability actions have any impact in the experience of the patients. And I would like to ask you if, do you think, well, it is well known that the health systems is one of the most polluting systems in the world, and those are one that makes the less to decrease their wastes. And I would like to know if you have any plans to make any partnership with the health systems, specifically with hospitals, to start providing them with plastics, the biodegradable plastics, or make any partnership with the health industry?
Well, it's a tremendous question. I think both, we need to answer both Roberto Parra and I to you. Let me tell you that we have a tremendous collaboration with the medical school here at Tec de Monterrey. In fact, we have been working with Dr. Jose Antonio Diaz, who is a guy who specializes in all these surgeries, hernia repair surgeries, and so on. So we have developed two materials, those important materials. One for hernia repairment, and we found that in fact we can move into also to use our material development in an additional surgical procedure that you have specifically for those people who has problems with, we may say it, with this food, how do you call it, food problem? Food diabetes problems. So we have created those, and we have also the other project that is a very strong one, in which we have also managed jointly with the medical school to create hydrogel for knee replacement also. So we have a lot of activities running with the medical school, and now let me mention to you that sustainability is a big issue for us nowadays, because as you may think, by having something inside the body, you don't want to be biodegradable, but you want it to be biocompatible. And if you want it to last just exactly what is needed to last inside the body, right? But of course, you have a lot of medical devices that you can use outside the body, and it's something that we are going to be taking care of. For instance, all the devices that we are using when you have blood transfusion and so on, so there is a lot of waste that is created nowadays. So by adding these new formulas and enzymes that Dr. Parra were mentioning to us, I'm pretty sure that in fact we are going to find sustainable solution for the medical products that you are nowadays using. And Dr. Roberto Parra, if you wanted to add something,
Thank you.
comment.
Thank you, Doctor. Yes, well, definitely the medical sector is very important. It has a huge potential because of all the syringe, plastic, polymers that they're using. So yes, we're currently working with basically the effluent, the water that is coming out of the hospital because the high load of antibiotics because they have an effect on the resistance of bacteria. But definitely we will work on different polymers. If we can talk, we can find solution and make some prototypes to start with, so some trials.
Thank you.
You're welcome.
Okay, I have a question. I understand now, well, Roberto Parra is working from bio-waste to create new type of materials that are, this life cycle assessment is net zero emissions, whatever. But Alex, in your case, the materials used in the automotive industry and aerospace industries has a different life cycle assessment. And I mean, they cannot all be bio. So what are the things that you are thinking of solutions on using what type of material so the life cycle assessment will be net zero? Have you think about it? Both of you, of course.
Well, in that case, the life cycle assessment is a very good tool, as you said, for assess the reusability of the transformation of a product again into raw material for another product. That's the circular economy. Of course, it's different. I think if we're talking about something that is biological than something that is metal-based, but definitely at the end we need to make it everything renewable, make it again regenerated from its form. So for that, I think we need to make, again, as Dr. Elias mentioned, that part of the difficult part of degradation need to be designed again, probably with bacteria, new bacteria or enzyme that allows to break down even metals. So, and again, I think we are at the breach of starting a new phase for humanity. The process is still not there, Arturo. Need to be designed, but definitely that will be my answer. It's a challenge.
Yes. Speaking about, for instance, aerospace industry or automotive industry, it's a good question. But let me tell you something. In aerospace industry, they are facing now a lot of waste because a lot of aircraft are ending their life cycle. So they are just asking for us a potential solution because aircraft have been built by instance using glass fibers, and we are using some additives and polymeric resins and so on. So they are concerned about how they can recycle those kind of things. So, of course, the period between recycling this, that it takes maybe 1 year or 2 years compared to an aircraft that it must be close maybe to 80 years or 100 years, it's a big difference. However, we need to think ahead. There is another example that I can provide to you in lubrication. Many operations to manufacture some components in the automotive and aerospace industry requires lubricants, okay? So they are asking about how they can enhance the life of those lubricants in order to be or to have the same properties. So they are using now some additives, they are using now some special, I may say, bacteria in order to enhance those properties. And I may mention that because we were working together in close collaboration with Honeywell Aerospace, who launched an internal project in that sense. So that is feasible, that is possible. So we have a lot of challenges to face, and we now, the only thing that we need to do is to change the way we think about product development. So this is very important. There is another example coming from Siemens company that is here. Siemens Mexico, we were working together just to replace a thermoset by a thermoplastic material. We have achieved up to now, with great success, that goal. So this is a great example of how also industry are moving into a new scenario in which they are caring about green manufacturing, but now also in blue sustainability. and this is important. So we can provide a lot of examples about that, but now I think that the Mexican government needs to play a fundamental role into push and to create the awareness of the blue sustainability culture that we need to have into all of us. Me as a mechanical engineer, but in the rest of the world, we need also to create this culture and this awareness. So this is.
Thank you. Thank you, Dr. Zuniga, for this talk. Now, continuing with the agenda, our next speaker is Tim Hoff, in the name of Richard J. Magnan, who couldn't be here, President and CEO of BioPro Global, who will present to us the short talk, How Sustainability is Covering the World in Haze of Plastics, Biodegradation, Biopolymers, Water Diffusion, Fracking Oil, and Gas. Thank you.
Thank you again. And Richard Magnet really sends his deepest regrets for not being able to attend. And he does say the next time we have this kind of conference or collaboration, he will be here. He had a family emergency and had to cancel last night. But he sent me a quick little synopsis of what he wanted to cover with you guys here. And to give you a little background of Rich, Rich has been building and also in the biopolymer industry for over 20 years. So he's a leader globally. His products are in over 32 countries around the world. He also just doesn't do bioproducts. He works, for example, in the oil and gas. He does evaporations, clean water treatment. So he's a leader in sustainable and clean technologies. But I'm just going to read Rich's quick statement that he wanted to discuss with you guys and show kind of his vision of where he sees the future is going. So this is from Rich. At BioPro Global, our mission is commitment to helping reduce the amount of environmental waste pollution caused by the plastics globally. As plastic consumption continues to increase annually, so does plastic waste pollution and the impact on the environment. BioPro Global strives to increase awareness of environmentally friendly biodegradable plastics and the sustainability to help reduce this waste now and in the future for a cleaner, less polluted planet. Plastic is everywhere we look, in our oceans, our rivers, landfills, even our food. We wear it, travel in it, and save lives with it. Plastic makes our lives better, yet today it is becoming one of the most hated materials on the planet. Despite how important it is to us, BioPro Global has solutions for all types of plastics. Humans have created almost 9 billion metric tons of plastics to date, outgrowing all man-made materials other than steel and cement. This is why biodegradable additives are getting more attention now, because it is very hard to replace a plastic product with an alternative material and be able to do the exact function at that price. It has taken many years to get this message out, but it is finally starting to trend inside our homes and inside governments. BioPro Global is preparing for the future of growth. We are now working with our new facilities in Texas, United Kingdom, and in China. Even as businesses aim to design circularity into their products, BioPro Global is working closely with our customers to bring more circular solutions, while still being able to address potential leakage of plastics into the environment by using EcoPure to help reduce the time they persist. EcoPure is totally sustainable and assured. Best regards, Rich Magnet. Now, just to give you a little bit background, I've worked with Rich for a number of years, and how he found me was because of my M4 film. I had no idea about the Plastics Institute and Technology, or Plastic Awards, that is actually hosted by MIT and put on in Massachusetts. I got an email from Rich Magnet 8-9 years ago saying, we want to invite you to Boston and come see a baseball game, and we want to talk to you about your amphora film. I had no idea about the Plastic Institute of Technology and what was going on. They were awarding me for this. I just read free plane ticket, and I get to go watch a Boston Red Sox game. And I showed up, met Rich, and Rich and I have been friends and collaborated on over 20 different patents together, and continuing to do trade secrets and continue to work on bioadditives. But again, next time he is available, he will want to be down here and meet all of you. Thank you, guys.
Thank you, your phone. Yeah. Okay, well, thank you for these interesting words from Richard. Now, next to in our agenda is the brief panel, Circular Sustainable Pathway, the Blue Future, which will be held by Arnulfo Mendez, co-owner of International Clean ASW, Timothy Hoff, CEO and owner of Colorado Clean ASW, José Alfredo Pérez Bernal, General Director of the Institute of Innovation and Technology Transference of Nuevo León, Dr. Arturo Molina, Director of the Institute of Advanced Materials for Sustainable Manufacturing. First, we will hear some words of Arnulfo Mendez, co-owner of International Clean ASW. He is an expert in international commerce, skilled in negotiation and marketing, creating international opportunities for companies, strong business development, professional with a bachelor's from Universidad de Monterrey, UDEM, more than 30 years of experience in sales, sales development, marketing development, and international projects focused and based on one-of-a-kind technology and sustainability. Please, Arnulfo, this is yours.
Hola, muy buenas tardes. Esta es una junta disruptiva y voy a empezar disruptiendo a través de hablar en español, ¿ok? Espero que no les moleste, el único que no me va a entender es Tim, pero le estoy forzando a que aprenda español, ¿está bien? Entonces, ¿es el verde? Ok. Aquí hay algunos datos para explicarlo del plástico, creo que ya todos, cada vez tenemos una conciencia un poco más profunda de lo que está pasando con el plástico. El plástico por ahí sabemos que es sumamente necesario, que con el tiempo va a ir creciendo su consumo de manera bastante importante, pero tenemos que encontrar soluciones a esa gran cantidad de plástico que se nos está escapando al mar. O sea, al final lo puedes tirar en una montaña, lo puedes tirar en un landfill, en un río, pero todo esto al final termina en el mar, y en el mar está generando cosas verdaderamente interesantes, que es el principio del fin de la vida, ¿no? Entonces, hay más de 8 millones de toneladas de plástico que se vierten al océano cada año, y esto, de acuerdo a lo que ya nos platicaron, va a ir incrementándose año con año. Desgraciadamente, algunas otras alternativas son escasas, el aluminio, el vidrio. Entonces, tenemos que resolver el tema del plástico porque es necesario que continuemos utilizándolo. Se calculan 5 trillones de piezas plásticas en los mares. Más del 90% de las aves tienen plástico en sus estómagos. Y en México el 20% de los peces, según Greenpeace, tiene plástico en sus estómagos, con las consecuencias que nos platicaba el doctor Alex, ¿no? Por ahí hay diferentes números, depende de la fuente que consultes, pero no varía mucho. A nivel mundial solo el 9% del plástico es reciclado y en México solo el 6.7%. Y no podemos decir que no se han hecho esfuerzos para poder reciclar más. El tema es que es costoso, el tema es que operativamente se dificulta y entonces teníamos que encontrar una solución distinta al reciclaje, porque estos números después de algunos años no son nada alentadores, ¿sí? Entonces, por ahí, buscando buscando por la vida y la vida apareciéndote enfrente de ti. Lo que encontramos fue a Tim Hoff, que ahora desapareció, pero volverá a aparecer. Pero hablamos de que si bien el reciclaje era verde, tenemos que olvidarnos del verde y matizar ahora azul, ¿sí? Y azul significa biodegradar. Y biodegradar sumado al reciclaje creo que es una de las herramientas mejores que tendremos hoy para enfrentar un futuro más sano. Entonces es una nueva tecnología totalmente disruptiva que en este caso fue creada por Tim Hoff y que es a favor del planeta. Logramos una biodegradación de entre 13 meses a 3 años. Claro, hay ciertas variaciones porque los landfills, depende el tipo de microbio en términos de humedad y en términos de temperatura, lo que podría variar, pero no es mucho más allá de los hoy actualmente 500 a 1000 años que se biodegrada algún artículo plástico y que en el proceso genera esos famosos microplásticos que se han estado transformando en nanoplásticos y que esos hoy desgraciadamente ya no es posible filtrar y que se están yendo de los basureros a tu estómago, pasando por ese proceso de disrupción de cadenas y llegando al mar. Con este tema de aditivos que ha desarrollado Tim Hoff, esta nueva tecnología disruptiva que verdaderamente las empresas, los seres humanos, las nuevas corrientes de pensamiento y morales y demás estaban buscando y que ya se encontró. Gracias a este aditivo que es como la preocupación de todas y cada una de las empresas, que lo que se utilice sea economía circular en términos de impacto en el costo y que lo que se utilice sea asimilable en sus procesos de producción. Eso es lo que Tim logró resolver en términos de economía circular. Y también les preocupa mucho a las empresas el desempeño que este producto plástico tuviera en el mercado y que se pudiera ver o no afectado. Entonces, con esta biodegradación, estos aditivos creados, estos 40 y tantos aditivos para aplicarse a 100 y tantos polímeros, que constituyen más o menos el 99% de los polímeros existentes, desde el ánfora que creó Tim hasta recorrer todo hacia el futuro, hacia la parte del caucho, la parte de las llantas que había sido tan complicado hacer algo con ellas. Bueno, hoy ya se logra biodegradar en corto periodo de tiempo. Se conservan las propiedades físicas, mecánicas y químicas de los productos. La biodegradación inicia hasta que el objeto se coloque en un vertedero. Permite que el producto sea reciclado, según estudios de laboratorio, hasta 30 veces y además puede ser todavía compostable, y su uso no requiere ninguna modificación de proceso productivo actual. Requieres de 0 centavos de inversión para añadir estos aditivos. Es como tan fácil como añadir un pigmento para colorar. Platicando con empresas, una de las empresas bastante importantes que genera juguetes, lo que decía es: llevo invertidos millones de dólares, muchísimos investigadores, diferentes países, concursos internos y demás, y no hemos logrado resolver el tema del color. Entonces aquí se ha logrado resolver. Es una aplicación que afortunadamente existe hoy y que está ya disponible, aplicable en el 99% de los polímeros existentes en el planeta. Pero no importa que aquí las mentes brillantes estén presentes y quieran, no importa que la gente del gobierno también quiera, no importa que las instituciones nos abran la puerta, eslabones aislados no funciona. Tenemos que crear una cadena y esa cadena tiene que ser un círculo virtuoso. Entonces, nos tenemos que unir científicos, centros de investigación, empresas, gobiernos, ciudadanos, ¿sí? Tenemos que formar esa cadena, sumar esos eslabones, porque esto es una oportunidad verdaderamente para salvar el planeta a través de biodegradar y sumar al reciclaje. Y tenemos que pasar definitivamente del tema del concepto a la acción. Y creo que hoy estamos uniendo un eslabón más a través de estas puertas abiertas del Tecnológico de Monterrey, de Tim Hoff, con esa apertura que ha tenido para contribuir a salvar al planeta, sus trabajos que ha tenido en África, ahorita buscando en Tulum, Quintana Roo, el tema del sargazo, lo que hizo ya en Colorado, su asociación con las Naciones Unidas. Esta asociación de mentes brillantes y de voluntades también que está teniendo TEC, sus científicos, con Tim Hoff, para mí es verdaderamente un placer. Y como por ahí me presentaban, soy egresado del UDEM, pero orgullosamente con 3 hijas en el TEC y verdaderamente satisfecho de que me hayan abierto las puertas aquí para trabajar esto y todo lo que falta, porque si bien tenemos listo la parte de polímeros biodegradables, hoy ya en esta alianza que estamos teniendo con el TEC de Monterrey e International Clean, vamos a pasar muy rápidamente, porque ya están las bases, nada más es escalarlo a volumen, a biopolímeros, y por ahí también vamos a tener la proveeduría de sargazo. Todo eso lo queremos meter en biodigestores, pero de gran escala. No es nuevo la biodigestión, pero lo que sí va a ser nuevo y disruptivo es el volumen que vamos a lograr. De ahí vamos a pasar a generar energía para que muevan máquinas, y con esas máquinas lo que queremos es la captación atmosférica del agua. Y bueno, esa agua la vamos a guardar en biopolímeros biodegradables. Y por ahí vamos a empezar a sumar algunos otros esfuerzos, como decía el doctor Roberto Parry, que me gustó mucho, es que a la par de esta línea de trabajo que traemos en conjunto, al mismo tiempo, dice el doctor Roberto Parra, necesitamos pegar la tierra rota. No basta con captar el agua sin utilizar los recursos, porque lo va a otorgar biodigestores que vienen de plásticos biodegradables, etcétera. Todos y cada uno de nosotros tenemos un compromiso, como por ahí decían, sembremos ese chip, y se está haciendo de manera muy importante en las nuevas generaciones, que nazcan con ese ADN de cuidar al planeta, que se sumen esfuerzos del gobierno, que se sumen esfuerzos de instituciones, de científicos, de gente como yo, que no hago absolutamente nada más que unir puntos, y también hacen falta esas piezas. Entonces me estoy justificando de por qué estoy aquí, pero bueno, no importa. Que le hemos hecho mucho daño a la tierra, tenemos que empezar a curar la tierra, tenemos que empezar a retomar ese ciclo de vida que parte del agua en las montañas, y luego la nube, y luego que llueve y demás. Hay plásticos en todo ese proceso. Entonces tenemos que quitar metales de la tierra, tenemos y de verdad se está trabajando en ello, y tenemos que hacerlo a escala, y tenemos que hacerlo circular. Entonces, lo importante es que estamos hoy, aquí y ahora, con soluciones circulares positivas, y trabajaremos muy fuerte de verdad para lograr lo más que se pueda en el menor tiempo posible. Por ahí mencionaban, este es el hoy y el ahora. Tenemos que pensar en las generaciones futuras, pero resolverlo precisamente hoy, si no, no tendremos generaciones futuras sanas. Entonces, pues la verdad es que muchas gracias, estamos a sus órdenes. Gracias, azules. Ahora, como dicen, blue is the new green, así como orange era el new black. Bueno, y pues blue, thank you.
Thank you, Arnulfo Méndez. Now, moving on, due to the time, we won't have questions for Arnulfo, but we might have some. Okay, yes. But now we can have any other question that you might have, or if there is a comment that you would like to do, Jose Alfredo or Dr. Molina, if you would like to give us some comment on this panel about circular, sustainable pathway, the blue future, or Dr. Parra, is there a comment you would like to address, or someone who would like to address any comment or question?
Thank you for today, of being here. I would like to invite you really to create a new culture. That's really what's important. We have to change our own habits first. You know, I was asking Tim the question on house culture. You know, we have to really go from what we do and how we behave in every day and our habits of consumption, so we can change the other things. But secondly, we invite you, all of you, to really join the Institute of Advanced Materials. We are really focused on that idea that we want to really achieve net zero emissions manufacturing, net zero emissions new materials. And if you are really interested in joining us in research and also in all our programs that we are going to launch in the following months, you are most welcome. And thank you, Roberto, thank you, Alex, thank you, Jose Alfredo, thank you, Tim, and all the speakers that joined us today. And I pass the microphone to Jose Alfredo.
Thank you very much. I will speak first in English and then Spanish for everyone. What do this have to do with me? Is the first question. ¿Qué tiene que ver esto conmigo? It has to be all. Tiene que ver todo con nosotros. Y como gobierno, en la parte de los compromisos que ha asumido el gobierno del Estado, el gobernador nos ha instruido que las planeaciones que hemos estado haciendo sean desde los objetivos de desarrollo sostenible. Es decir, tenemos una ley de planeación estatal. We have a state planning law, and we are achieving the ODS in this government, this local government. Y si bien son compromisos internacionales, Nuevo León los ha hecho suyos, no solamente como una parte de una responsabilidad para México, sino también para Nuevo León. Y me regreso al principio cuando platiqué del tema de la crisis del agua. También tenemos una materia de trabajo con el ambiente, con el aire limpio que necesitamos en Nuevo León, ahora que somos prácticamente más de 6 millones en el área metropolitana, casi 6 millones de habitantes, cuando solíamos ser hace algunas décadas no más de 3 millones. Entonces ha sido un crecimiento muy, muy agresivo. ¿Y qué tiene que ver todo esto con nosotros? What do this have to do with us? And I say again, everything, todo. ¿Por qué? Porque empieza desde lo más básico. Obviamente hay una mayor responsabilidad en el gobierno en la parte de fijar las políticas públicas que se necesitan para que esto suceda. Tiene que dar el primer paso y obviamente a través del Congreso y a través del Ejecutivo, etcétera, se hacen leyes. Pero ¿de qué sirven estas leyes si se quedan solamente en el papel y no terminan teniendo acción? Entonces, we have to create a new conscience to make sure that our legacy for the new generations begins today. Tenemos que asegurar que nuestro legado empieza hoy para las próximas generaciones. Me voy a quedar con la frase de Arnulfo al final que decía, blue is the new green, el azul es el nuevo verde. ¿Por qué? Porque va más allá de decir, está bien, reciclar, y aquí lo vimos y lo dijeron, reciclo y tú como ciudadano lo pones en una bolsa y lo separas, pero llega el camión de la basura y se va a donde mismo. Entonces dices, ¿dónde quedó el esfuerzo? Yo les digo, sí hay un esfuerzo porque al final del día, al menos en el sistema estatal que hay de CIMEPRODE, sí hay ese procesamiento y separación de bienes, y la gente que lo hace sí tiene una consecuencia final porque sí termina separándose la basura, pero a veces pareciera que no va a ningún lado. Ahora, esa es en esa parte. ¿Qué pasa con los objetos más grandes? Los electrónicos, etcétera, y hay que cambiar de teléfono cada rato porque todo el mundo llegó el nuevo modelo, etcétera. Todo eso tiene un impacto que a veces decimos, ¿y eso qué tiene que ver conmigo? Tiene que ver todo con nosotros, porque nosotros mismos, si no empezamos por nosotros mismos, eso no va a generar ningún cambio en ningún lado, y por más esfuerzos que se hagan en la sociedad, en la academia, en el gobierno o quien quiera que lo emprenda, no tendría mucho sentido porque vamos tarde, vamos muy tarde, y esa es la parte de la conciencia que estamos teniendo hoy. Y agradecerles, I want to thank you, Tim, and Richard, and the tech community for the invitation, y decirles que estamos dispuestos, estamos con un gobernador joven, pero con buena preparación, que nos ha inculcado y nos ha dicho facilitar todo lo que tenga que ver con hacer un cambio, pero un cambio real y sustentable que deje un mejor legado, no solamente para lo que estamos haciendo ahorita, sino para las próximas generaciones, que esa es nuestra responsabilidad el día de hoy. Muchas gracias a todas y a todos ustedes.
Thank you very much, José Alfredo. Now moving on to our agenda. I would like to welcome on stage Dr. Arturo Molina and Timothy Hoff, who will celebrate the Office Collaboration Agreement of the Institute of Advanced Materials for Sustainable Manufacturing with International Clean ASW. It's going to be representative. This is unofficial. Thank you. And thank you all for your kind participation in this event. On behalf of the Institute of Advanced Materials for Sustainable Manufacturing and to all of our attendees this morning, hoping we have gained as much as input as possible and have inspired you to be the innovators we will need in the sustainable manufacturing. With that said, I would like to invite you to the coffee break, and I hope you have enjoyed these conferences. Thank you. Dijo silente,